This is Unit 7, Day 2, Part 2. So we were just graphing this graph. So if this is negative 25, this is negative 12.5, and I have to be down at negative 20.7. So I'm over at negative 2.3 and down. Here's approximately where my minimum is. Okay, so there's that graph. Moving on to example 12. The largest root of x cubed minus 9x squared plus 12x plus 22 falls between what two consecutive integers? Okay, so the only thing I did was I went to practice finding the zeros. So now it is talking about the roots. So the roots are the zeros. So if you just put this function into a graph page, and then you're going to menu, number 6 is going to analyze the graph, and then number 1 finds the zeros, which are your roots. Okay, you have 3 roots there, and you want to pick the biggest. So pick the one furthest to the right, and it ends up being at 6.730. So now, between what two numbers does that 0 fall between? It falls between 6 and 7. Example 13. Consider the quartic function. It's now quartic because your highest degree is 4. So now it says algebraically determine the x-intercepts. So x-intercepts are when y is 0. So I put 0 equals x to the 4th minus 5x squared plus 4. Now you might say, oh my gosh, we have never factored x to the 4th. But imagine that that said x squared minus 5x plus 4. Then you guys would factor that and say what multiplies the positive 4 and adds to a negative 5. It's the same thing. But you can't place x's in the first spot for when you're trying to do a FOIL check. You're going to put x squareds, because x squared times x squared would be x to the 4th. But then when you add your outers and your inners in FOIL, it will still be combined like terms and get you an x squared. Okay? So what two numbers work? It's going to be a negative 4 and a negative 1, because a negative times a negative will be positive, but then negative 4 minus 1 will be negative 5. Now hopefully you realize that you can do, hopefully you notice that there can be a DPS done. So this is a difference of a perfect square on both of these. So you do have to take that one step further. This becomes x plus 2 times x minus 2. And then this one becomes x plus 1 and x minus 1. So we have lots of zeros here. So we have, it could be negative 2, it could be positive 2, it could be negative 1, it could be positive 1. Okay, now it says graph those. So we know where all the zeros are. So here's negative 2, negative 1, positive 2. And then again, you're going to look for maxes and mins. So use your analyze graph. So my max is at negative 1.58, negative 2.25. My min is at 1.58. So if you notice, those are just differences of positive and negative signs here for your x values. Okay. So you also have a y-intercept at 4. So if this is 5, you're going to have 1, 2, 3, 4. There's a y-intercept right there. Okay, so those are things nice to look for too, is your y-intercept. And remember, y-intercepts are where x equals 0. So you can go to your table of values, and on your table of values, it would tell you 0, 4. Okay, so there's your y-intercept as well. That's a y-intercept. Okay. All right. So negative 1.58, and then it has to go down as low as negative 2. So this would be negative 1, 2, 3, 4. So negative 2.25. Okay, so it's going to be right around here. Okay, so this has a little turning point right there. There's your minimum. Oh, sorry guys, that's not a max, that's a min. It has 2 minimums. Okay, so there's that one, and it's going to come up here. And then the same thing's going to happen over in this area. And so you get like this W figured shape. So one little correction here, guys, I had to make. Those were both minimums. Okay, it says don't forget the calculator allows you to find the roots of any polynomial function, polyroot finder, see calculator notes. So you could use your polyroot finder as well. All right, last example here. Consider the Quartic function y equals x to the fourth plus 3x cubed minus 35x squared minus 39x plus 7. Sketch the graph. So lots of using analyze graph here. So lots of stuff. So I put that in the graph page. I know I have zeros at -7, -2, +1, and 5. Again, guys, I analyzed the graph, menu 6-1 to get those zeros. Y-intercept, okay, you just look at your table of values. The y-intercept is where 0, or x is 0, so that's at 0, 70. And then I have one max on here. The max is at -0.5, 80.5. And then I have two separate mins. One is at -5.2, -364, and the other min is at 3.5, -217. Okay, so that's everything in the graphing calculator. Now it's just making your scale appropriate here. Okay, so making the scale appropriate, let's start with my zeros first. So this would be -5, this would be -1, 2, 3, 4. And then this would be 5, 6, 7. I know I have one at -7. I know I have one at -2. And then again, same thing over here. So here's +5. This would be 1. There's one at 1. 2, 3. I gotta space these a little better. So 1, 2, 3, 4. It's at 1. It's at 5. There's my zeros. Okay. And now 500 is your scale here. So this might be 100, 200, 300, and again, you're seeing it, I'm not spacing them that good. So 100, 200, 300, here's 400. So those are going by hundreds. 100, 200, 300, 400. Those are going by hundreds as well. So the first y-intercept is at 70, so this would be like 50, so 70 is going to be like here. That's my y-intercept. I have a max at -0.5, 80.5, so it's going to be a touch higher than that y-intercept. And so look at this. There we go. There's one of the turns right there. Okay, there's my max. And then I have a min at -5.2 and -364. So it's going to be like right around here-ish. And that's going to be over at -5.2. So it's going to fall somewhere right around here. And again, are they super accurate? No, but it's definitely more accurate than you just drawing it in freehanded. All right, my last min is at 3.5. 1, 2, 3. Here's 3.5 right there. And then -217. So maybe right around there. So then I do this and done. All right, based on part B, based on your graph in part A, write the expression in its factored form. Now guys, don't forget, your zeros were -7, -2, +1, and 5. So its factors are reversed. X plus 7, X plus 2, X minus 1, X minus 5. What does that mean, guys? If you took the time to foil this and then multiply those, you're going to end up with this Quartic function right there. Okay, so one thing in this little box here, it says the connection between the zeros of a polynomial and its factors should be clear now, stated below. Your zeros, which are your roots, are opposites. Okay, that's a key word there, guys. They're opposites of your factors and vice versa. So when your roots were -7, your factors were +7. Or you could think of it this way. If your factor was x plus 2, then your root was -2.